Hi, so let's look at another example that involves coming up with a Laplace transform of an initial value problem that has a step function with it. Okay, so the first thing that I'll do is that I will come up with a Laplace transform of my initial value problem, and I've been given these initial conditions right here. If you're not given initial conditions, then that's not an initial value problem because an initial value problem is simply a differential equation together with an initial condition which specifies the value of the unknown function at a given point in the domain. Okay, so I'll say the Laplace transform of my differential equation, which is y prime prime plus 3y prime plus 2y. This is just going to be equals to, I can write this as, I'm looking for the Laplace transform of my y prime prime. Remember to say the Laplace transform is linear, so I have like 3 multiplied by Laplace transform of y prime, then plus 2 multiplied by Laplace transform of y. So what I mean by linear is the property of the Laplace transform that enables me to write this into that is what we mean when we say the Laplace transform is linear. This works for addition and subtraction. It does not work for division and multiplication. Okay, so let's determine the Laplace transform of that one. So from the formula of Laplace transform of derivatives, we get that this is just going to be s squared multiplied by um, the Laplace transform of y. Okay, so I can choose to write it that way, but I'm just going to, instead of use Laplace transform of y, we just use capital Y of s. Okay, by the way, you can check the formula for the Laplace transforms of derivatives in the description below. So this will be minus s by y of 0 minus y prime of 0. Okay, then that will be plus 3 open bracket here, that will be s by y of s minus y of 0, like that, then plus 2, then that will be your y, like that, but I will choose to write this as y of s, like that. Okay, so for this part, this is just going to be s squared, then that will be y of s minus s y of 0 minus y prime of 0 plus 3s, that would be 3s y of s minus 3 y of 0 plus 2 y of s. So looking at the initial conditions that I'm given here, y of 0 is 0 and y prime of 0 is also 0. So you get 0 here, you get 0 there, you also get 0 there. But it's so interesting in the fact that this and that is the same, so I can factor it out. Hence I just remain with s squared plus 3s plus 2 multiplied by y of s, like that. And that is the Laplace transform of my initial value problem, which is just simply s squared plus 3s plus 2, then y of s. Okay, this is equals to, so I have this as a step function. I need to write it as a unit step function or the Heaviside function. So for this part, it's just going to be 4t open bracket. So the way in which I'm writing, this is the simplest way you can write. There would be other complicated ways. Okay, they're not really complicated, but they are different from what I'm writing. But I believe, or I recommend, this is the simplest way to write, to transform from a step function to a unit step function. That is after you shift. So the unit step function is shifted. Okay, so you move it from that, you want to write it in terms of what I'm writing here. Okay, so this is, you're going to have a 1 here because of the presence of the 0 there, minus u of t minus 1. This way I've gotten the 1 from there. Then you close the bracket there. Then that would be plus 8 by u of t minus 1, like that. Okay, so I can now choose to expand this. This is just going to be 4t minus u of actually minus 4t u of t minus 1 plus 8 u of t minus 1, like that. Okay, so now we need to find the Laplace transform of this our unit step function. But before we do that, we need to ensure to say all the terms are shifted by the right amount. Okay, and if you observe this part here, I don't need to shift this one because it has no t variable, but this one here is being shifted by 0 term, of which is correct. So the only part that needs the correct shifting is the middle part. So here you're going to have like 4t minus 4, so where there is t, I'll put t minus 1 plus 1, like that. Then u of t minus 1 plus 8, we say 8 u of t minus 1, like that. Okay, so um, you can expand this part. That would be 4t. If you observe, I haven't changed the meaning. This is u 4t simply because I have minus 1 plus 1. So I can write this as 4. So to separate this, you just, this part here, let me name this as my a, this part as my b. Okay, so that would be 4 t minus 1 u of t minus 1. Then I get the minus 4 again. That will be minus 4 multiplied by this one multiplied by this part here. That will be our u of t minus 1 plus 8 u of t minus 1, like that. Okay, so we can actually choose to simplify a work for ourselves looking at what we have here. Okay, so this just ends up to be like 4t minus 4, then you have your t minus 1 u of t minus 1. Then here this is more like this and that are the same, so those are more like they're like terms, so you can add or subtract. That you're just going to end up with plus 4 u of t minus 1, like that. Okay, so now we can go ahead and find the Laplace transform of this, which is something that is not hard to do if we know the second shifting, as well as how just to differentiate the unit step. I mean, if we know the second shifting, as well as how to find the Laplace transform of a unit step function. Okay, so for this part, I'm looking for the Laplace transform of, let me put the 4 outside. I'll say 4 multiplied by I'm looking for the Laplace transform of t, then I'll say minus 4 by the Laplace transform of t minus 1 multiplied by u of t minus 1, then plus 4 multiplied by Laplace transform of u of t minus 1, like that. Okay, so for this part, I just end up with 4 over s squared. Okay, then for this part, what I end up with, I'll say my minus 4 multiplied by, for this part here is simply 1 over s squared multiplied by, so for this part I'm going to get okay, let me just say for everything here, it's just simply going to be e to the minus cs, but in this case my c is a 1, so that's just minus s, plus that would be 4. So the Laplace of this one here is simply e to the minus cs, which is just c is minus 1, sorry, c is 1, so you're going to have minus s divided by minus s divided by s there, like that. Okay, so let's see how this ends up to be. So this is what we have. I can choose to simplify this for myself by writing this as, since the common denominator is s squared, so that would be 4 minus 4e to the minus s, plus for this part you're going to have 4s e to the minus s, then everything divided by s squared, and that's what I have. So we are getting a bit closer, not really close, but a bit closer to our final answer. So that is 4 minus 4e to the minus s plus 4s e to the minus s. You divide everything by s squared. Then from at this point here, you can choose to, I want to leave the y of s on its own, multiply everything by 1 over s squared plus 3s plus 2. In fact, I can factorize this in advance before I even do this. I can factorize that in advance. So on this part, you observe to say I have like s squared. I'm factorizing that. Then I can say plus s plus 2s plus 2. That's simply s plus 1. Then you have your 2s plus 1. So that would be 1 divided by s. That would be s plus 1 multiplied by s plus 2. Okay, so what I come up with is y of s, which is equals to 4 minus 4 e to the minus s plus 4s e to the minus s, then divide everything um, divide everything by, we have our s squared, that would be our s squared, then that would be s plus 1, then s plus 2, like that. Okay, so let me choose to separate everything here. Okay, let me actually write this as 4 over s squared, then that would be s plus 1 multiplied by s plus 2, then minus 4e to the minus s divided by s squared s plus 1 multiplied by s plus 2, then that would be plus, that would be 4e to the minus s divided by s, then s plus 1 s plus 2. So you observe to say I haven't written squared here, and it's simply because I've cancelled out this s that I had here. Okay, so let me bring this back on the top there. I actually don't think I need the question. If I need it, I'll have to think of bringing it back. Okay, so my y of s, we have said is equals to so for this part it will be 4. Let me use g of s for this part here, 1 over everything on the denominator, then minus 4e to the minus s multiplied by let me use h of s plus 4e to the minus s, let me use q of s, like that. Okay, so what this one simply means is that you're looking for the inverse Laplace transform, because I have to write this in terms of y of t, not y of s, and this is supposed to be lowercase a y. So here the inverse Laplace transform of everything here, okay, of everything here, my y of s equals to 4 g of s minus 4e to the minus s by h of s plus 4e to the minus s q of s there, like that. So this one is supposed to be written as, we're supposed to have it as y of t equals to our 4 multiplied by lowercase g of s minus 4e to the minus actually this will also be looking for the inverse of that. I'm just going to say h of s actually not g of s but g of t, sorry about that. That will be g of t minus, that will be 4, then h of, I'll say t minus 1 because of the shift there. Okay, of the shift. Then here you have u of t minus 1. You do the same to this one, that will be 4 by q of t minus 1, then u of t minus 1. So this is how it's supposed to be. So all we have to do is just to find our g of t, h of t minus 1, and q of t minus 1. Okay, and by doing that, we would have found the answer. So all we have to do is just to find the inverse of this, inverse of that, and inverse of that, and inverse of that. Then we are good to go. Okay, so let me go ahead and see if I can determine this step by step. So this seems to be a bit long, but um, we have to find a solution. So we have to find it. So here it's quite evident to say, from what we had, our g of s was equals to 1 over s squared, s plus 1 by s plus 2. Okay, so if you are to break this one down into its equivalent partial fractions, this is actually interesting. So this, you can just write this as a over s plus b over s squared plus c over s plus 1 plus d over s plus 2. So this is the format that you're going to use to break our g of s down into its equivalent partial fraction, so that at least we'll be able to come up with the inverse. Okay, so if you follow these step by step, okay, if you follow this step by step, or you can do it how you do it, then you should you observe that the answers that you're going to get is a bit long. So your a, okay, your a um, your a is going to be equals to minus 3 over 4. Then your b is going to be equals to 1 over 2. Your c will be equals to 1. Then your d will be equals to minus 1 over 4. So just follow these same steps, break this one down into its equivalent partial fractions, and that's what you're going to get. So what does this tell us? It tells me to say my g of s, I can write it as my a, which is minus 3 over, and put minus 3 over 4, that is divided by s. My b, which is 1 over 2, that is 1 over 2 over s squared. My c, which is just 1 over s plus 1. Then my d, which is minus 1 over 4 divided by s plus 2. So if I look for the inverse Laplace of this one here, what do I end up with? I end up with g of t minus g of t. Actually, let me not just look at g of s. Okay, let me not just look at g of s here. Let me write it this way. Since my g of s, let me see, actually it's just g of s. I was thinking it is also multiplied by the e to the minus s, so it's okay as just inverse of that. Okay, so for this part you have your g of t being equals to, for this part, what you're going to get is it's just minus 3 over 4 the way it is. Then for this part you're going to get plus, this is actually 1 over 2 multiplied by 1 over s squared. The inverse is just simply 1 over 2 by t. I can just write this as t over 2. Then for this part, that would be plus e to the minus t, okay, because the Laplace of e to the at, we say is equals to 1 over s minus a. Yeah, that's that. Then minus, if I've made a mistake, try to correct it for me. Then for this part is just be simply equals to be equals to 1 over 4 multiplied by e to the minus 2t, which is just going to be equals to e to the minus 2t divided by the 4 there, like that. So this is what you plug in at this step, at on this one here. So it seems a bit long, but this is our g of t. That's our g of t. Let me write it on the on somewhere here. So we say our g of t is equals to minus 3 over 4 plus t over 2 plus e to the minus t minus e to the minus 2t divide by 4. That's what I get as my g of t. I'll substitute it later. Then let me find my h of t. So I have my h of s. Okay, um, my h of s is also equals to my g of t. Okay, your h of s equals to g of t. So it simply means your h of s is equals to your g of s. So meaning your h of t is also equals to minus 3 over 4 plus t over 2 t over 2 plus e to the minus t minus e to the minus 2t divide by 4, like that. That's what we have. So what is remaining is to find our q of t. So we have our q of s to be equals to 1 over s plus 1. Then you have your s plus 2, like that. So this can be written as 1 a over s plus b over s plus 1 plus c over s plus 2. So we also have to break that one down into its equivalent partial fractions. Okay, so as well as this one, I want you to go breaking down into this as a partial fraction step by step. You can try to do that, but this is the format. So if you follow this step by step, you observe that you're going to find your a to be equals to excuse me, your a will be equals to 1 over 2. Your b is going to be equals to minus 1. Okay, your b will be minus 1. Then your c is going to be equals to 1 over 2 as well. Okay, so meaning your q of s, okay, your q of s will be equals to your a, which is 1 over 2 over s, then your b, which is minus 1 over s plus 1, your c, which is 1 over s plus 2. So if you're looking for the inverse Laplace of this one here, I know I'm supposed to find it together with this one, but don't worry, I'll bring that part back. Okay, so meaning my q of t is equals to this is just 1 over 2 minus, that will be e to the minus t, then this part, that will be plus e to the minus 2t. Okay, e to the minus 2t. By the way, this is 1 over 2, so that will be divided by 2. So there we have it. Our q of t is equals to 1 over 2 minus e to the minus t plus e to the minus 2t divide by 2. Okay, so now we are now looking for the inverse Laplace transform of everything here, like that. So for this part, you observe that what you're going to get is simply y of t is equals to then 4 multiplied by your g of t, minus 4 multiplied by your h of t. But because there is a shift here, and the Laplace of this one here, like for this whole entire part, you're going to have your h of, instead of saying t, that will be t minus 1 u of t minus 1 there. Then you do the same for this part as well, a similar thing. So that's going to be 4. Then you're going to have your q of t minus 1 again here, looking at the shift, multiplied by u of t minus 1. So I've already found this, that, and that for you. Just have to substitute here, here, as well as there, like that. Okay, but just make sure to say for this part and this part here, Anywhere where there's a t here, you have to shift it by what? You have to shift it by 1. So if, for example, here that would be t minus 1, that would be t minus 1, that would be 2t minus 1, and something like that. Yeah, so this one right here is what we are going to end up with. So I've already given you that. Just go ahead and substitute and take note of the shifting, and that's how we answer that one. Thank you very much for watching.